Today we're going to be factoring the difference of two squares. But before we get into that, let's go over what are your perfect squares, because you will be using these quite often. These are the typical ones you use most often. Your perfect squares from 1 to 12. So you got 1 squared equal to 1, 2 squared is equal to 4, 3 squared as in 3 times 3 is equal to 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared 121, and 12 squared 144. So we'll be referring to these perfect squares throughout our examples. When we're talking about factoring the difference of two squares, the vocabulary in the title kind of tells you exactly what's going to happen. The word difference means subtract, so you're going to be subtracting in each example. Two squares means there are two perfect square terms. Okay, so let's look at our first example. Our first example is x squared minus 25. Okay. Now, as you can see, it's only two terms here. And there is no middle term. Okay, so there's no middle term here. So really all you have is an A and a C. Okay, and because there's no middle term, that means one answer will be positive, the other will be negative. Okay, so now we just got to fill in the other parts. So when you're looking at x squared right here, x squared is a perfect square. To get x squared, you have to do x times x. And to get, and then when you look at 25 here, 25 is a perfect square. 25 is 5 times 5. So your final answer is x plus 5 times x minus 5. That's your final answer. Just that simple. Okay, let's look at number 2. Example 2 says y squared minus 121. Again, there's no middle term. There's no middle term. There's no middle term. One answer is positive, the other is negative. Y right here, y squared, is a perfect square, and it is y and y. 121 is also a perfect square, and it's 11 and 11. So your answer is y plus 11, y minus 11. You see how this looks? And it's not as difficult as you think. It's usually the same routine every time. Let's look at example 3. Example 3 looks slightly different. Still doing the same thing. Example 3 says for z squared, subtract 1. So when you're looking at this 4z squared, both the 4 and the z squared are perfect squares. Square root of 4 is 2, and the square root of z squared is z. Then you know one is going to be plus and the other is going to be minus. And then when we look at 1, square root of 1 is 1 and 1. So your one answer is 2z plus 1, and the other answer is 2z minus 1. It's going to work like that every time. Basically, you have the same term. The only difference is one has a plus and the other has a minus. That's the only difference. Like in number 1, you still had x, and you had a 5 and a 5. It's just that a plus was in this one and a minus in the other one. Number 2, you still had a y and 11 in each one, but one's a plus, one's a minus. And in example 3, you have 2z and a 1 in both, just one's a plus, one's the minus. It's going to work like that each time. So let's look at example 4. Example 4, we look at this. 16m squared is a perfect square. Square root of 16 is 4. Square root of m squared is m. Then you got this 49 here. Square root of 49. Oh, let's do this. One's a plus, one's a minus. So square root of 49 is 7 and 7. So one answer is 4m plus 7. The other answer is 4m minus 7. That's how you're going to get that middle term to eliminate, because one answer is positive, other is negative. So when you do FOIL and you write it out, you'll see it's eliminated. As a matter of fact, let me just show you this just so you know that is the case. So if we do the FOIL method for 4m plus 7, 4m minus 7, okay, so we got our first, and 4m times 4m is 16m squared. All right, then we got the outside. So that's 4m minus 7m, which is minus 28m. Then you got inside, and that's 7 times 4m, which is a positive 28m. And then you got your last 7 times negative 7, which is negative 49. And as you can see, a negative 28 plus a positive plus 28, it actually equals 0. So you won't write 0 in the middle, you just eliminate that middle term. So then it just becomes 16 squared minus 49. That's how there's no middle term. Because when you do the FOIL method, because one's positive, one negative, it eliminates the middle term. So just so you know why there's no middle term. Okay? Again, that's using the FOIL method to check that your answer is correct, because you should get the original problem back. Now, our last two examples we're going to do is factoring a perfect square trinomial. So in the first four examples, we had a difference of two squares, which means there's only two terms. There's no middle term, so they're very quick to do. And factoring a perfect square trinomial is also quick if you recognize certain pieces to let you know where the perfect squares are. But if you don't, I'm still going to do the original method, and it'll get you the same thing. So let's look at it. If we notice that the first term and the last term are perfect squares, and we see that n squared is a perfect square, so we're going to say n and n. Okay. And then we know that 16 is a perfect square, which is, so we're going to say 4 and 4. Now, the only difference between the first four examples we did is because there is no middle term, one's positive, one's negative. But here, going back to day one, or our first day of factoring, if the C is positive, C term is positive, and the B term is positive, that means both answers will be positive. Because see, now you got a middle term. And if you got a middle term, that means both of these numbers got to be the same sign. That's the only way you can get a middle term. When they're different signs and they're kind of like the same terms, then that's when you get something eliminated. All right. I'm going to also show you the factor sum method and show you that even if you did factor sum to do this, you still get the same answer. The reason why we do just factor sum is because the coefficient of the squared term is 1. So to do the factor sum method, we always write the factors of the C term. And since C is positive and B is positive, that means both of your factors should be positive. So you got 1 and 16. You got 2 and 8. And 4 and 4. 1 plus 16 is 17. 2 plus 8 is 10. 4 plus 4 is 8. We're looking for our middle term right here, which is 8n, which is the 8. We see that the only ones that give us the 8 is at 4 and 4. So then we just fill in our answer. We write the variable first. We know that both these are positive numbers, and we fill in the numbers for it. And as you can see, same answer. Same answer. different methods. There's always more than one way to solve a math problem. It just depends on what you remember and what's easiest for you. If you recognize right away that, oh, your first term and your last term are both perfect squares, you can get right down to business. But in case you don't, that's okay. Go back to your original. Do your factor sum method. You'll get the same answer. Example 6. All right, example 6 is 4x squared minus 12x plus 9. Now, in this example, our x squared term is a number other than 1. So that takes us back to the last lesson that we did where we used the x method to find, to factor because there's a term other than 1. But if you recognize that the first term here is a perfect square and the last term is a perfect square, you can get right down to business. So 4x squared, the square root of 4x squared is 2x. 2x. Square root of 4 is 2 and 2. Square root of x squared is x and x. Then the square root of 9 is 3. So you write 3 and 3. Now what are your signs in the middle? Because you got a middle term, either both are positive or both are negative. If the one's positive, one negative, they can't be the same terms because if they are the same terms, you're going to have the middle term eliminated. And here, we actually have a middle term. So since C is positive and B is negative, both have to be negative. A negative times a negative gives us a positive, but a negative plus a negative gives us a negative. So then that's our answer right there. That's if you recognize the perfect squares in the first term and the last term. But if you don't, let's go to our X method. If you don't recognize that, we're going to go to our X method where we can factor that way, and we'll see that we actually will get the same answer. So when we're doing the X method, okay, we remember we are going to label our A's, B's, and C's, and that's your coefficient. So A is 4, B negative 12, and C positive 9. Okay, so on this first part of the X, we are going to multiply our A and C. And our A is 4, our C is positive 9, so that's 36. Then we're going to write down our B. Our B term is a negative 12. Remember, the sign in front of it goes with it. All right, now we're going to find the factors of. You're always going to find the factors of whatever AC is. So we're going to find the factors of positive 36. Now, again, because the C is positive and the B is negative, that means both your factors must be negative numbers. That's the only way you're going to be able to multiply it and get a positive, but add it and get a negative. So we got negative 1, negative 36. We got negative 2 and negative 18. We got negative 3 and negative 12. Then we got negative 4 and negative 9. And then we got negative 6 and negative 6. Now we're looking for a middle term of negative 12. So the only numbers that when you add them together gives us a negative 12 is this right here, negative 6 and negative 6. Because negative 1 plus a negative 36 is a negative 37. Negative 2 plus a negative 18 is a negative 20. Negative 3 plus a negative 12 is a negative 15. Negative 4 plus a negative 9 is a negative 13. But a negative 6 plus a negative 6 is a negative 12. Jackpot. So going back, remember, we're going to write a negative 6 here and a negative 6 here. Those are our two terms. And we're going to divide by whatever A is. So we're dividing by 4. Reduce your fraction. So that's going to be negative because they both divide by 2. Negative 3 over 2. Negative 3 over positive 2. Then our last step, you do your bottoms up. which means you take your denominator and you write that first. So bottom, so we got 2x, and that's a minus 3. And then this is a 2x minus 3. And lo and behold, look at here. Exact same answer. Same answer, different method. Same answer, different method. All right. And that's factoring a difference of two squares and factoring a perfect square trinomial.